In this video, we're going to continue looking at more instructions. Specifically, we're going to look at our goto. And so our goto instruction, as we see over here on the right, is an unconditional branch. We do, however, have an operand. So we have one operand, which is offset. And what we can see from the purple highlighting is that this is a 2-byte offset. And so what that means is because we have 2 bytes or 16 bits, we have 2 to the 16th different possibilities. And this is actually going to be assigned values, so we can actually sort of go to or branch in the backwards direction. So we can go from negative 32,768 to a positive 32,767. So that's sort of the range that we have with this goto. One important thing to note as well is that that offset is relative to the PC at the start of the instruction. So offset is relative to our PC value at the start of the instruction. And so of course this is the start of that goto instruction, and so let me just really highlight that, right? So we're talking about at the start, and we'll see how that makes things a little bit trickier. We have to take into account something that we normally don't have to. But we actually saw this as we were looking at an example, and that example is on page 4-19 in the notes on Canvas. And so in that example, we were looking at how we could compile a simple Java code to our specific architecture using our MAL, our microassembly language. And so we had a couple branch statements. One of them was actually an unconditional branch. One of them was conditional. We'll talk about an example of a conditional branch in the next video. But in both cases, when we were looking at the number of bytes of instructions that we skip, remember we had to count the number of bytes that were in that goto or that branch instruction itself. And so that's what this is saying, right? So we're offsetting relative to the start of the goto instruction. And we'll see how that all works out in terms of the registers here in a minute. So if we come down here again, like normal, we can start by considering our ISA level instruction stream, which again is going to be bytes. So ISA level instruction stream, and these are our bytes, and of course these bytes are being pointed to by our PC. They're being fetched into our MBR. And so in this case we have 3 bytes. The first one is going to be our goto statement, right? So we have goto, and we can see the exact hex value if we come up to this page. And so of course this again is from page 4-16 in the notes on Canvas. But we see for our unconditional branch goto, the hex value is A7. So coming down here with goto, we can write in parentheses that this is hex A7. Now, following that, we're going to have 2 bytes for our offset. So we can call this first one, we'll just say this is offset byte 1. And over here, this is going to be offset byte 2. And just like with all of our other examples, of course, we have some instructions coming before that, some instructions coming after that. You'll notice that I have these instructions labeled arbitrarily as being at address n+1, n+2, as we've seen in a previous example. Of course, in practice, that would be some absolute address. I'm just keeping it general with some variable n. So that, of course, you know, the following instruction would be n+3. The one preceding goto would be n-1, and so on and so forth in each direction. And so coming down here, we can see our sequence of micro instructions for our goto statement. So we see in this case, our micro instructions, we have 6 of them. So I'll write 6 micro instructions. And so as we've talked about for all of our other ones, the number of micro instructions is the number of cycles through our data path. And again, like we've normally done, I'm going to go ahead and write in our main 1 as well, because we're always sort of coming back to that eventually, or starting from there. So our main 1, of course, is just going to be incrementing PC. So PC equals PC plus 1, initiating a fetch, and go to MBR. So there's our main 1. And so again, the main reason I usually like to include that is so that we can know when this fetch is going to be available. We can talk about, sort of as we're coming back to main 1, we can talk about our MBR, our PC, and all that stuff. So let's keep that in mind. Let me maybe move this down a little bit so I have room to reference those n values. And so also what we're going to do is we're going to keep track of 4 registers here, our PC, our OPC, which we've not used up until this point. So far we've just said that's a scratch register, but really what we're going to see is that's going to be to keep track of our old PC or our old program counter. And then of course on the right we've got our MBR and our H, and we're just kind of going to track what's going through here. So let's start by saying what do these registers look like at the start of main 1. So let me switch back to the pin there. So at the start of our micro instruction main 1, well, of course we know that our MBR is what we're going to. So if we're going to, it's kind of becomes weird, right? Because we're going to the Goto instruction, but we're going to this unconditional branch Goto 1. And so as we saw in the table on the previous page, and as I had written in the box down there, that's going to be hex A7, right? So hex A7. So at the start of main 1, our MBR is going to have a value of hex A7. Our holding register has something, but we don't know what it is, so I'm going to leave it blank. But of course, there's some value there, so maybe we just put a question mark. Of course, we would know that if we knew the specific instructions here and what they were doing. But for our purposes, we don't know what that is. Similar for OPC, we don't know what that's been used for, has something, we don't know what it is. And then our PC value at the start here is going to be pointing at N, right? So this is at the start, so we're pointing at N. And maybe let me do what I did in the previous video, and let's do this in a different color. So let's say we have our PC pointing here. Now again, remember we're talking about the start of main 1, so we've not incremented yet, but of course that's what we're going to be doing sort of in the next one when we look at the start of Goto 1. So this fetch, and let's just talk about this briefly before we move on. So this fetch in main 1, so that's not going to be available until Goto 2. So this is available, and of course that's going to be available in MBR at the start of Goto 2, and we'll update our register here in a little bit once we get to our Goto 2 register, or our Goto 2 micro instruction, rather. But for now, let's say we finish main 1, and so now we want to know what our registers look like at the start of Goto 1. And so of course, in main 1, what we had done is we had incremented the program counter, but those registers again don't get loaded until the end of our data path cycle. So coming down here, we can now say our PC at the start of Goto 1 has been updated to N+1. Our MBR, because it's not had time to fetch yet, is still at hex A7. We've not done anything with H, we've not done anything with OPC yet. We can see we're about to, but we've not had time to do that yet. So we still don't know about those other 2 registers. So what we're doing in Goto 1, as you can see on the right, is we're saving the address of the opcode. And so this is related to how we said before, how we have to offset from the start of the instruction, right? So notice our PC has already moved to be not at the start of the instruction, but we need to know where the start of the instruction was if we're going to offset from there. So what we can do is we can say our OPC is just equal to whatever PC is minus 1. So we're just going back in time 1 essentially. Again, that's not going to get loaded until the end of that current cycle. So if we come over here and we say, let's look at what things are at the start of Goto 2, well, now we have a couple changes to make. The first one is we have uploaded this OPC register, we've updated it. That's going to now have a value of N. And so that, of course, that N is just coming from PC minus 1. So we look at what's in PC, we subtract 1 from it, and we get our OPC value of N. The second thing to consider is now this MBR is available, right? So this MBR comes into this register, and so that's what PC was pointing at. And we can see, didn't mean to erase, so we can see our PC is pointing at our offset byte 1. So at the start of Goto, we're now going to have, and let me get rid of our hex number because we don't know the exact value, but we're going to have offset, and I'll just put B1 for byte 1. So we have that in our MBR. So that's what conditions look like at the start of 2. Let's now look at what we're doing in our instruction 2 itself. So we're incrementing our PC again. And so of course that's important because we're going to need that second offset byte eventually. So let me go ahead and move this here. So we're moving our PC to our second part of our offset byte. The other thing that we're doing is we are initiating a fetch. Again, with any memory cycles, what we saw on page 4-6 in the notes on Canvas is that's going to take 2 cycles until that's available. So we can say this is available 2 cycles later, and of course that's going to be an MBR. And so we've initiated that fetch, we've incremented our PC. Those registers, our PC register is not going to get updated till the end of that cycle. So let's then talk about at the start of Goto 3. So at the start of Goto 3, that PC register has been updated. So now that is pointing to N plus 2, as we see in the picture above. But we still only have offset byte B1, right? So we still have to wait a little bit of time for that to get loaded here. So that's not quite updated in the MBR. Our OPC by design is still pointing at N, and our H register we haven't used quite yet. But that's about to change. As we can see in our Goto 3, we're now storing in H, our MBR shifted left to the 8. And so notice this is not an unsigned value, right? So this is a signed value, and that's because, as we said up above, remember this value, this offset, we set as signed, so that's why we get the potential for a negative offset or branching to addresses that came before our Goto. And so because of that, we put the signed value into our MBR, from our MBR into our H register, and we're shifting that left 8. So what we can do then is we can go on to instruction 4, because that H register doesn't get loaded until we go to the end of that cycle. So at the start of Goto 4, now what we're going to have in our H is we're going to have offset byte 1. So we'll say offset byte 1, but it's going to be shifted to the left by 8. Also, this fetch that was initiated 2 instructions ago is now going to be available in MBR. So we can come down here and we can say this is no longer offset byte 1, but now this is offset byte 2, which is available in our MBR register. And our PC hasn't changed, our OPC hasn't changed. What we're doing in our Goto instruction 4 now is we can see we're setting H equals to MBR unsigned or H. And so of course H has our offset byte 1. So real briefly, what we can do is we can look at what this looks like. So let's say, for example, this is a signed number. So our offset byte 1, we can do in purple. So maybe we had 1101, 1101. So maybe it's just something like that. So there's our offset byte 1. We've shifted that. Well, first of all, we put our sign extended version on. So when we put the sign value on, we're going to get 1111. Clean up that next one there. 1111. And then we'll just get 1111, 1111. So we'll have 3 bytes. So here are upper 3 bytes where we've just sign extended that. So we've looked at this highest order bit and we just extended that to the left. And so that just goes back to how we put the MBR on the B bus. And so what we did though in our offset byte 1, and let me sort of move this over a little bit. When we loaded that, we said let's load this value and then let's shift everything to the left by 8 bits. And so what ends up happening is we end up losing these 8 most bits. So let's delete those. We shift these over and we shift in zeros. So I guess let me keep that as blue. So we shift in zeros. And so what we're going to do next is we're going to have our offset byte 2, which let's do in green. So here we're going to say maybe this has a 1 as well. So maybe we get something like that. So this green would be our offset byte 2. And so what we'll step through here in a little bit is, well, let's just take a look up here. So what we can see right here is we're doing our MBR unsigned. So we're putting this onto the B bus unsigned. So what this looks like is now we just have these upper 3 bytes are 0. So we have 0 for that byte, 0 for this byte, and 0 for that 4th and final byte. So we get something that looks like this onto our B bus, and then we're ORing that logical OR with what is in our H register, and so that's what's shown right here. And so the ultimate effect is that if we had some negative value, like I had in this example, we can see, of course, we're still going to have that negative value, right? So we'll have our upper 3 bits, or our upper 2 bytes rather, not bits. So our upper 2 bytes are going to be unchanged. We're then going to have our offset byte 1, and our offset byte 2. And so that just comes from anything being ordered with zeros, of course, itself. And so there is our final 16-bit offset, and then of course these are just indicating it's negative. You could go through and do 2's complement of that and see that all of these would go to 0. Okay, so coming back up here then, what we see is that, again, we just did that ORing process to get our H register. So now our H register at the end of this cycle, or really we could say at the start of Goto 5, is going to have our signed 16-bit offset. So let's go in here, and let's say now we're going to have our 16-bit offset, and we'll put down here in parentheses that it is a signed offset. So that's stored in H. And so what we do in the next line in Goto 5, and so that's the only thing we've updated. So we still haven't initiated any other fetches. We've still not incremented our program counter. So what we're going to do now is we're going to say our PC is going to be equal to OPC plus H. So basically what we're doing is we're setting our PC, well, we're not getting rid of that just yet, so let me keep that there for a second. So that was n plus 1. So we're setting that PC equal to whatever our program counter was at the start of the instruction. So what were we before we came into Goto, or just as we came into Goto, and we're adding our desired offset. And so when we do that, of course, we're going to have some number in PC that's not going to be shown there until the very end of the Goto 5 cycle or the start of the Goto 6. And so let me maybe just go ahead and say, let's look at the start of Goto 6 then. So at the start of Goto 6, what we'll have in our PC is N plus our 16-bit offset. And so of course what that's going to do is that's going to send us to wherever we wanted to go in the code. So coming back to the Goto 5 line though, we can see that we also in this line have a fetch. And so we know that's not going to be available until 2 cycles later. And so what is 2 cycles later? Well, our 2 cycles later is going to be in main 1, because in Goto 6, we are going to main 1. So now we're going back to main 1 up here. And so of course we can see part of main 1 is we're going to our MBR. We're also incrementing our PC. So our PC, this fetch that we initiated in the PC here, so that is getting the instruction of wherever that points to. That is then putting it into the MBR. So let me come down here and update this. And let's say at the start of main 1, so we've kind of come full circle now. So at the start of main 1, now we're going to have whatever, and let's see, the best way to put this would just be whatever this PC is pointing towards where we wanted to go to. So whatever our PC points to, we've now loaded into, and that ultimately is what we're going to be going to the next time we go through main 1. So that's how we would handle our unconditional branch. And so what we're going to look at in the next video is one example of the 3 types of conditional branches that we have.